Welcome to the tutorial on how to craft an electric motor. My name is Fitzviandra Duiven Althaf Budiyanto, and I am here with my partner.
Hello, my name is Satya and Sulistio, and my class number is 30.
We are engaged with a task to build an electric motor. Before we get to know what is an electric motor though, we must first understand the basic and famous principle of energy. Remember, energy is infinite. It can neither be destroyed nor be created. First law of thermodynamics. Postulated by Julius Robert Mayer in 1842, it is considered as an important foundation in physics. The principle in general claims that energy can only be transformed from one type into another. This is why when we eat food, we feel better when doing other activities. The chemical energy found in nutrients of food is then transformed into kinetic energy that is responsible for our body movements. Now, let's talk about electric motors. Invented by Thomas Davenport in 1834, electric motor was a masterclass engineering. While it functioned to print newspapers initially, changes and upgrades have been made to further help humankind. Nowadays, you'll find electric motor in your blenders, your vacuum cleaners, your printers, fax machines, video cassettes, cars and motorcycles, sewage systems, water pump stations, and so forth. So, how can one answer? How does electric motors work? What is the science behind it? What is the mechanism of one of the revolutionary inventions in human history? We'll discuss that later in the last segment. But for now, let us build a new electric motors that you can even do in your house. Materials. To craft an electric motor, we would first require a AA battery, neodymium magnet, although an ordinary magnet should suffice in case you didn't have one, a block of wood with size to your own favor, insulated copper wire, and a tape. Step 1. The first step is to form the insulated wire into a loop by wrapping it around the AA batteries. Cut both edges of the wire and then fold them into 2 times through the loop. Open the insulated part on both edges and avoid damaging the wire insides at all costs. Step 2. Cut 2 insulated wires and remove the insulation on both ends. Sculpt the copper wire with your own hands into the S letter.
Proceeding to the next step, attach the wires to the block of wood with an insulated tape. Curve both wires' end around 90 degrees, approximately. And then, proceed to place the loop floating with the S-shaped wires as its legs. Step number 4 is to place the magnet below the floating loop. To activate the circuit, connect the wires to the AA battery. Now, the solenoid or the loop will spin. This spin is caused by mechanical energy that originated from the electrical energy. Now, let's talk about the science behind it. Recently in grade 12 with Mr. Ramaturyadi, we as students have learned about magnetic field and electric current, and when both interacted, they will form what we call as electromagnetic field. To explain this any further, let's resort to the topic of electromagnetic induction.
Electricity produced by magnetism. For Ampere, the question was particularly cogent. Magnetism as ordinarily induced.
When a magnetic field occurs to a certain direction, in this case, it's going up, it's heading up, and it's placed nearby an electric current, an induction will happen. And this certain induction will cause what we call as a force to push the loop, to spin the loop. And this force is called the Lorentz force. This force causes the upper and the lower part of the loop to move in a different direction. The Lorentz force direction can be decided using the Maxwell's right-hand rule. Now, in the rule of Maxwell's right hand, the thumb is the electric current, the direction of the electric current, and then the direction of our fingers, the rest of our fingers here, the four of our fingers, it's the direction of the magnetic field. And there's an angle created between these two. Now, the forehand in the rule, it stated that this is the direction of the Lorentz force. So let's say if there's an electric current that goes this way, and then the magnetic field goes up, then the Lorentz force will go into that direction, to the front. You'll notice that the Lorentz force, the direction of our forehand, will always be perpendicular towards the direction of the magnetic field. And that is the direction of our fingers, our forefingers. And also, if there's a deviation from 90 degrees angle between the electric current and the magnetic field direction, this will affect the calculation of Lorentz force, additionally multiplied by the sinus of the degree. So we can derive now the formula of Lorentz force, and that is the magnetic field times the electric current times the length of the wires times the sinus degrees between the electric current and the magnetic field. Now in the circuit, notice the different directions between the upper part and the lower part of the loop. This is the reason why the loop keeps on spinning, because there is a force, the same amount of force, that works in two different directions between the upper part of the loop and the lower part of the loop. So now we know, in general, that an electric motor requires, first, a battery or any source of electricity. Second is cable or wires. These cables are used to run the electric currents from one pole to another pole. And then the third, we need a magnet. This magnet will create what we call as the Lorentz force, and this Lorentz force will birth motion so that an item or a certain things can move, can spin, can make movements in general. So that's all from us. If there are any mistakes in this video, we are deeply sorry. If there are any questions about the procedure or the science, please leave the comments down below in the comment section. And also, hopefully this video is beneficial for all the viewers. And we'll see you around. Good luck.